A very good afternoon to all of you. I am Priyanshi welcoming you all on behalf of eMobility Plus and First Video to our webinar on transforming EV manufacturing smart and agile. Before we dive into the discussion, let me give you a quick overview of what to expect from today's webinar. As we know, we are in the era where sustainability and technological advancement converge, and the automotive industry is witnessing a paradigm shift towards electric vehicle manufacturing. As the world marches towards a greener future, the demand for EV continues to soar, necessitating a transformation in manufacturing processes. In this context, the webinar on transforming EV manufacturing smart and agile aims to delve into the intricacies of EV production, leveraging Industry 4.0 solutions to meet the evolving demands of the market. This webinar aims to unravel and deepen the understanding of EV manufacturing landscape, covering market trends, challenges, and opportunities. Explore integrating Industry 4.0 tech for efficiency, productivity, and quality in EV production, and also discuss pivotal Industry 4.0 technologies like IoT, AI, robotics, automation for smart EV manufacturing enhancement. Address supply chain optimization and sustainability, emphasizing digitization and circular economy principles, and to offer actionable insights and strategies for navigating next-gen smart EV manufacturing with Industry 4.0 solutions. After the panel discussion, we'll have a Q&A session where you can ask the questions to our experts. But here, I would like to make a small request. Attendees can post their questions in the Q&A box and our expert will answer those questions at the end of the panel discussion. I would request you to post in the Q&A box and not the chat box. Before we start today's session, I would like to take this opportunity and invite you all for our upcoming event, the EV Manufacturing Show 2024, going to take place on May 23rd at Radisson Blue at Bengaluru. Join us and stay ahead in the dynamic world of electric mobility. I would request my team to play the short video of EV mobility.
Electric vehicles are changing the way we move. There is a sustainability in motion. It's silent but powerful. The future of transportation is here, and it's electric. Gear up for the biggest EV manufacturing event of the year. EV Manufacturing Show 2024, powered by eMobility Plus.
Okay, so it was really a great video and very much excited for this event. I am sure you must be excited too. So now, without any further ado, it's time to go to the discussion on transforming EV manufacturing smart and agile. And for this, we have in our esteemed panel Mr. Rabindra Shah from Tata Technologies, Mr. Sridhar Joshi from Zenith, Mr. Vivek Gusen from Tata Motors, and Mr. Prateek Shah from EY Parathon, who will be the moderator for today's session and discuss the discussion. So I welcome all the panelists on the screen and over to you, Mr. Shah. Please take it ahead.
Sure. Thank you so much, Priyanshi. And I think the video got a lot of us excited, at least me. And hopefully, a lot of us already had lunch, and we'll try to make sure that we'll not, let you sleep at least. That will be our endeavor as panelists. So quickly introduce myself. My name is Prateek Shah. I'm a partner with EY Parthenon, part of the strategy and transformation practice at EY. I've been focusing on automotive as a sector for over last 18 years, working back with multiple OEM suppliers as well as associations like CM and ACMA on multiple aspects within the automotive sector, be it manufacturing, supply chain, front-end transformation. Of late, over the past 4 5 years, a lot of focus has been on electrification as well, and that is, I think, one of the focus topics for us today. I have with me a lot of esteemed panelists, and what I'm going to do is maybe to set a little bit of context for the audience. I think we've seen a phenomenal growth in the electric vehicle sales in India, close to a triple-digit sort of growth we've been clocking every year. This financial year, and we kind of sold close to 1.5 million EVs in India, and where the penetration has almost reached about 5%. While a lot of portion is still attributable to two-wheeler and three-wheeler. If you just talk about passenger vehicle segment, close to $5 billion of investment on building capacities have been planned by multiple OEMs over the next 2 to 3 years. Also, what I think one fillip that government is also giving is introducing a lot of favorable policy initiatives for EV manufacturing and local manufacturing. To be very specific, of late we've also seen government coming up with a new policy to reduce the duty on imports while focusing on local value addition, and that will also see a lot of fillip again to the localization happening in the country, and also giving boost to the local supply chain. Having said all of that, EV manufacturing is definitely quite different as compared to traditional IC manufacturing. And given the geopolitical situation that we have, a lot of dependency on specific rare earths or minerals, which is there at the same time, quality issues or the kind of skilled manpower which is needed to build out the entire manufacturing ecosystem. Those are definitely going to be challenges for us, given that we've just started on our EV journey. And that is what we'll try and focus on today, and seek views from our esteemed panelists, and see how smart manufacturing can help us address some of these challenges while we are building a robust EV ecosystem, not only for India, but also for catering to global EV requirements. I think the first question which I have for all the panelists is, given that the adoption has already crossed 5% of the overall market, and given the robust ambitions that the industry has as well as the government has on electrification, how crucial is the need for smart manufacturing of EVs as compared to IC vehicles? And what I'll request each of the panelists is, before you answer the question, you can also do a quick introduction about yourself and then answer the question, and accordingly then we'll take it forward. Maybe I'll start with Vivek, since he's at the center of it, and Tata Motors being the pioneer as far as the passenger vehicle segment is concerned. We'll definitely love to hear your views on this in terms of the smart manufacturing aspect in EVs as compared to ICs, how imperative it is today.
See, point is, if I look at the EV versus ICE, and if we do the process comparison, so I find that with ICE as a baseline process and EV getting over that, it's basically an incremental contribution that EVs have over ICE from manufacturing perspective. Technologically, yes, the technology is definitely different. So I would say that before we talk about ICE versus EV, we must first understand that it's the technology transformation. It's It's basically designing and producing EVs and ADAS platforms is not just about R&D or capital investment. It also requires mindset change, which OEMs need to understand. So if I talk about the specifics of ICE over EVs, then we have different components going into that. Unlike in ICE vehicles, where we have components like the engines, the conventional internal combustion engines, pistons, valves, crankshafts, etc. EVs, they just use the electric motors in place of that. It's very easier in terms of the complexity as compared to the IC engines design. Over and above that, we have battery packs as instead of fuels. So definitely, smart manufacturing is an imperative, which is a prerequisites as such uh, for EV manufacturing as compared to ICE. Why so? Because of the technology which the EVs are bringing forward to. See, um, besides the electric motor, it is the battery management system, which requires lot of smart algorithms and controls in order to protect the specifications of that, and which is very important for the performance of a EV vehicle as such, and some of the components which are very sensitive from the passenger safety perspective. So the smart manufacturing initiatives that we have deployed at Tata Motors is basically right from the in the value chain, from the perspective of having a good control in the processes of battery manufacturing, in the process of the DC-DC converters, and also the assembly of these aggregates into the vehicle. And post the manufacturing of the vehicle, it is about the testing part. So because the EV vehicles also require different kind of testing methods, so we have smart initiatives taken in place of in terms of the testing specific for the EV vehicle performance. So these are some of the things that are very much in use, and they are very much required in case we have to go ahead, because the future is anyways going to be the ICE vehicle, sorry, EV vehicles as we move on. Yeah.
Sure, sure. I think a great perspective, Vivek. I think a lot of imperative is coming from the kind of technology which is going into the vehicle, which is definitely making it imperative to deploy smart manufacturing practices. Over to you, Rabindra, again, and you've been on the both sides of the table, both at OEM side as well as on a tech enablement side at Tata Technologies. What's your perspective in terms of and what kind of evolution you've seen, particularly in Tata Technologies, in the way you've evolved as an organization to support EV manufacturing?
Thanks, Pratik. Thanks for the opportunity. And as in today, I moved out from Tata Technology, and but I come with a background of more than 31 years of automotive experience, and I happen to be the large number of projects I have done in the automotive and the commercial vehicle, and deploy the technology in the domain. So having heard from the Vivek, the when we talk about the EV manufacturing is part and agile, right, and in the context of the EV, the one side is that we have got the mandatory requirement to be the sustainable and the supply chain. So, and we see that the kind of evolving is happening. So the product complexity is getting increased. There are large number of models are coming, large number of variants are coming because of the EV. So the two things is very important, that how we adopt the digital technology is the one side, and how this digital technology to be made as a kind of smart. So two things come in play. Is one is the product life cycle management. There are a lot of digital engineering technologies are playing the role, and other that we need to use the various levers to make the machines which is put into a machine and system and the processes where we can collect the data in the live, where the industry 4.0 plays a significant role. So in this role, as you said, that the product data always remain the central repository in the product life cycle management, and because of the complexity and because the model variance is increasing, it's very important that how we quickly adopt those changes, how quickly manufacture the processes. So from the design data, it moves to the data to the manufacturing. And the digital environment, we create the processes, we create the resources, we do the layout planning, we do the digital walkthrough, we create the factory flow, entire simulation. So entire thing is built. And it is right that because to save the time and cost is very, very important. So all these things are done in the digital environment, and the PLM being the single source of truth. The data flow is smoothly. Change management happen very smoothly in the product process and resources. So this is the way what the technology enable happens when we validate the entire processes and systems, and then you create the kind of software instructions, and then what resources, what process to be deployed, and what stations, and is very well connected. And then we go for the physical deployment. This digital technology makes you very smart to do the all kind of improvement in a very short possible time. And when the process systems are in place and validated with multiple iteration, then we open the product lifecycle and the tool to enable them the facility planner to take the data and start working on physical deployment. In some cases, it may be happening parallelly. So this is what is the ecosystem is very, very important, and where the digital technology which makes the manufacturing smart is very fast, and it saves the time, it saves the com. You can bring the product or changes a variant very faster into the market. So this is my opening context, and we'll build on top of this going ahead.
Sure. Thanks, Ravindra, for that. I think, as you rightly said, digital is at the center when we are looking at, and obviously digital, which enables the humans also on the shop floor
Yes.
more productive and effective. And I think I'll just try and see what Giridhar has to build on it. And I think the kind of work he's doing already is how can OEMs sort of augment their entire manufacturing ecosystem, and a lot of solutions around that. So Giridhar, over to you for your opening remarks on the necessity of smart manufacturing in EV, especially as compared to IC.
Yeah. Okay. Thank you, Pratik. Thank you, Ravindra and Vivek, for building a beautiful momentum to the talk. And yeah, I agree. The smart manufacturing is absolutely essential in the world of EVs, because there is one crucial difference between manufacturing and EV versus ICE. In the ICE, what we do is at the end of line, we fill 5-10 liters of fuel, and that's it. And the dealer has to check the amount of energy. It's not very combustible at the end of the at the end of line. The vehicle can ship with that. But if you're able to, but it can't ship batteries that way. You have to be very carefully be shipped with a limited amount of energy. So the manufacturing line has to be, or the system has to be smart enough to understand the amount of energy that is getting shipped out of, because the batteries, they all look the same, and they come in a certain charge state. And number two, because these are batteries that we are talking about, which are immensely more combustible than the normal fuel. So we can't get, let's say, 1,000 batteries and store them, in a store warehouse. That will be so just-in-time concept is very, very crucial for EVs, more so for EVs than ICE. And in fact, there is so we'll have to manage the supply chain of all the components, not just the batteries and the vehicle, but also of all the components. Only then will a vehicle roll out really fast and not sit with dead batteries or live batteries, I would say. So this is what we do: is we connect all the suppliers to a common operating system, where the OEM knows that where are my batteries, where are my headlights, taillights, indicators, etc., everything in one place, so that they don't spend too much time with sitting time bombs. So quickly these vehicles are assembled and rolled out. And having said, another point that Vivek made was the number of components. An IC engine typically has about 20,000 components. Typically, and 20,000, including all those pistons, camshafts, rocker arms, connecting rods, etc., etc. And not to mention the engine oil and all the wet components, and the front end accessories, alternators, and so many things. These get super simplified in an EV. It is just a single motor. That's it. And the alternator is taken care of. Don't need an alternator anymore. The motor itself is alternative and it's regenerating. So this simplicity also puts a lot of, pressure on that. You can't spend too much of time on manufacturing an EV. It has to be really fast, because you're already, the number of your bill of material has come down drastically by almost a factor of 1:100. So it's expected to, so your takt times are expected to be in really fast, much faster than the ice. So this puts a lot of pressure on the software that drives this, and hence you need smart manufacturing to take care of this. Thank you.
Thanks. I think a couple of interesting perspectives. I think the whole, I think shift in terms of the bomb, the kind of complexity that has been reduced, and also at the same time, what I believe is the kind of customization the customers are looking at for EVs. So I think both put together gives us more potential to bringing smart technologies on the shop floor. I think just to maybe discuss further on few
Yeah.
specific aspects, one of the elements which I wanted to hear Vivek's opinion on was how ready is the EV supplier landscape in India from a local manufacturing, and given that we've achieved immense amount of localization as far as IC vehicles are concerned. What's your take on readiness of the supplier ecosystem, and maybe two, three top opportunities which India has in terms of localization for few of the components, which currently we are importing from outside of India?
Yeah. So, as we speak, there's been a lot of transformation happening around building up the supplier base, component readiness in the country. I remember, visiting the Component Expo right after Auto Expo last year, in the say around February timeframe, in which companies like Anand Group and various other competitions, they are already through their collaborations and through their own design competency, they are already ready with all the EV specific components, whether they may be the electric motors or the DC-DC converters, or different kind of HV cables, and so on and so forth. So I feel that the supplier base is, the value chain is getting stronger, and as OEMs also, it is becoming very important for us to look in-house or look domestic. So as you know that battery pack is one single largest contributor in terms of, if I say, the value, or in terms of the weight, or in terms of the size of the component which are specific to EVs which get into a car. So there's been a lot of local battery manufacturing initiatives which have happened. Tata Goshan is one supplier whom we bank upon in terms of supplying battery packs to us. Electric motors are also being developed locally. In fact, there are some startups like Waves. I was in one of the seminars early this week, and this is one company which has developed their own electric drives themselves. So there's a lot of action happening. I feel that we are now chasing what has happened in China a few years ago in terms of the boom on the EV vehicles, wherein you find a lot of supplier base, lot of even small time OEMs which are churning out electric vehicles at different levels. So having said that, now if you talk about how do we optimize our production in the yeah. So I would say that it's we are using different technologies in terms of trying to have some logics or digital algorithm based in terms of lining up the electric vehicles. We are largest producer of electric vehicles in India, having a market penetration of market contribution of about 72%. So despite that, the percentage share of electric vehicles in our portfolio is not more than 30%. So we make 70% of the ICE vehicles. So that is how we are deploying some of the initiatives in terms of smart logistics, smart product planning, and smart testing methods in terms of optimizing our capacities, so that we do not have any impact loss on our productivities because of the complexities of building the electric vehicles into our product lines. So yeah.
Sure, sure. Great. I think given the kind of complexity which still exists in the EV supply chain, a lot of these digital initiatives will help at least smoothen out or make sure the production is not impacted and the quality is also sustained. Just taking
Yeah.
it further, I would like to seek Ravindra's views. Essentially, if you were to look at the role of PLM in right from developing conceptualizing a product until the time getting it on the shop floor and including the entire manufacturing sourcing assembly around it, how the role of PLM has changed, and have you seen the role of PLM changing given the kind of time to market which is also necessary to introduce EVs faster in market. So maybe if you could throw some view on the importance of PLM and what kind of role change has happened as far as PLM is concerned.
Thanks, Pratik. It's a very nice question, right? This is the way we are, the OEMs are using, OEM and to some extent tier ones are using to exploit their the product manufacturing. So when we talk about the product life cycle, is starting from the start to beginning of any product. So when what is being done is that just we heard about, then when you speak about the IC engine and we talk about the electric vehicle. So if you do the kind of comparison in terms of bill of materials, maybe that there will be in changes of around maybe 15 to 20% of the product or the bill of material or the parts, right? So the beauty of the product life cycle management is that the design data along with the bill of material remains in the core of the product life cycle management, and that is what we call the product. And when we do the process planning or the facility planning, because our objective is to consume these parts of on a particular model into the line, and we need to have a process in place so that we consume the line with the resources. So there are three terms always comes in the picture: the product, process, and resources. We have got the product, so we need to design the processes and the process to be executed with using what resources. The product, process, resources is very, very important. So if you have using the PLM technology or digital engineering, you have done the process planning, facility planning for one model, and when we are switching over to other model or its variant, then what we need to do is that the beauty is that only we need to do the process planning or the facility planning or simulation and validation only for the change number of parts, because the technology enables you to consume the existing processes and facility which are already 80% done. So only we need to change do the process and facility only the change part. And the nice is that this environment gives you that what are the impacted parts, what are the processes are impacted, what are the resources are impacted. So you visualize that, and then you do the process planning using digital, then it gives you that this is the process, this is the part to be made on this station, including the constant which you have put. Then the process sheet and then the work instructions all are gets generated, and the quality control documents are generated. So this product lifecycle management makes you to faster adopt the changes. That is what we call we can call it the smart manufacturer, you can call the digital twin, etc. So this is the way the customization, adoption of the streamlining the process are being done, and this is where if you see IC engine and we move to the EV battery, very fast cut cycle of the cycles are happening, and we do all the entire thing in a digital environment and gives the maximize the benefits. So this is what is adoption.
Excellent, Rabindra. I think definitely the importance of PLM is growing further. I think beyond PLM also, when it comes to really looking at getting the most amount of efficiency and quality on the shop floor, the concept of digital twin again is, I believe, gaining importance as far as EV manufacturing is concerned. And Giridhar, what are your views in terms of how digital twins can come handy? And what are the typical use cases that you've seen as far as EV manufacturing is concerned when it comes to leveraging digital twins?
Yeah, so thanks, Pratik. So typically, what we've seen is a vehicle to develop a vehicle is a very expensive, end of year to develop a new vehicle. And what happens is all that is done and the vehicle is launched. And then we follow all these PLM and other processes up to the end of line. And then what? And this is where our digital twin enters. Is basically it can still track each of those vehicles till their end of life. And what happens is basically the product lifecycle management is actually till the vehicle almost at still its end of useful life. For example, right now we are monitoring what happens to the battery. How is the battery being used? Some typical customers, what they do is they don't use a vehicle for a couple of weeks and they don't charge it at all. On the other extreme, there are other customers who charge it twice a day. So these can impact the life cycle of a component in a very different way. And because of this digital vehicle twin, we are able to understand its impact and feed it back to the manufacturer, saying that, hey, these batteries are undergoing these kinds of life cycles, or the vehicle itself is being driven in these conditions. For example, some customers may tend to, in commercial vehicles I'm talking about, commercial EVs, they may tend to overload their vehicle in a very routine way, which they're already used to doing on an ICE engine. The ICE engine technology has matured over the last 100 or so years, but the EV is yet to catch up to that level of maturity. And so we need tons of data to reach that ICE level of maturity. For example, 20 years back, we used to hear, axles braking on ICE engines, on trucks, I mean. But now it's a rarity to see axles braking or vehicles breaking down. And to reach that kind of maturity, we need tons of data. And we need to understand how the customer is using them, in what environments are they deploying those vehicles. So we need to understand the main elements like the man, machine, environment. So in what environment is being used? Is it being used in the Himalayas or the desert or the normal, the Deccan Plateau? What kind of environment is it being subjected to? Is the vehicle being subjected to? How is the driver himself using it? Is he a nominal driver or aggressive driver? And of course, how is the machine responding to these kind of inputs, these kind of variables? So this is fed back into the PLM system and says, these are the next level of things to be done. And so typically we've started in our software, we are giving a very high focus to the batteries because of two things. One is, people expect range on these EVs, which is a big, range anxiety is a big topic. So because being a digital twin, we can address the range anxiety. And also, of course, the life cycle of a battery, how it behaves or what it does, what to do for the next design. How do you develop the next design so that it can overcome these current issues? Thank you.
Just to extend that question, Giridhar, with you, I think one is we spoke about twinning, how important it is because the kind of technology which is being deployed in electric vehicles, the amount of data that we are able to collect from the vehicles when they are running is also going to play an important role in the entire product development as well as the manufacturing cycle. What are the kind of use cases you've seen wherein the data from vehicles is being harnessed and going as an input for production as well as from a product development perspective?
Yes, good question. So one of the biggest questions that all OEMs have is what is the range they want to give? Okay, so what happened was, so if we want to give 300-kilometer range, so typically on a Tata Nexon is a 300-kilometer range. But is that enough when compared to an ICE car? ICE car is like 500 to 600 kilometers. So, and to give those 500, 600 kilometers, you need bigger batteries, which makes the car more expensive. But then the question that our OEMs that we've been working with, they had to answer was, what is the typical use case of a vehicle? Do they actually drive it 300 kilometers in a day? Do they really need it? And so we started generating data to understand. I can't reveal the exact amount of data, but we could understand from the usage of vehicles that a typical 150 to 200 kilometers max is more than enough for a typical usage. There are very extreme cases where, they actually take for a 400 or a 600 kilometer range. But then out of, let's say, a million rides, if I get 80% rides at 200 kilometers, so that is I would say, fix the battery size at that range. So this is how we fed it back to the design, and we reduce the cost of the vehicle and optimize the battery size. This is a real life use case.
Quite interesting, and maybe I would like to invite Vivek as well, given that a lot of close to maybe a lack of Tata vehicles should be on the road, electric vehicles or maybe more than that. How are you harnessing data from the vehicles for further improvise, the manufacturing, production planning, and also maybe cater to the aftermarket requirements possibly, which are coming from electric vehicles.
See, our first portfolio that was from Tata Motors was Nexon. So if we look at, and the code name for Nexon was Kanger. Okay. So as we speak, uh, we are into the third generation of Nexon in terms of evolution on the EV variant of Nexon. So definitely, data is the one very important input which has driven the kind of evolution that have taken place in case of Nexon. So yes, you are very right that we very strongly depend on the data from the vehicle, the performances. See, one level of performance which is done by the company itself before the vehicle is handed over to the customer. But then despite that, there are different kind of variables, as Giridhar mentioned, no, in terms of the customer usage vis-a-vis what is company doing and the kind of customizations that go across. So this is a similar thing happens has happened does happen with Tata Motors also, in terms of aligning to the customer requirements. And unlike what Giridhar said, that yes, if I have to run say about 200 kilometers on an average, why I need to have a full charge range of say 400, 500, or and so on and so forth. But the one big factor which is there is that, see, an EV vehicle still is the second vehicle that people are owning. It is still not the first one, and the primary reason for that apprehension is that the long range. So these are some of the inputs which have been taken in from time to time and spread over not only on Nexon but other portfolios. We recently launched our Punch EV, and we have already in Tiago Tigor we have EVs which are largely on the commercial segment. So this data also helps us in designing and positioning of the vehicles from the perspective of whether they will be largely used on the personal basis or for on the commercial requirement. So that is how the range also plays a major important part of it. And as we talk about not only the range, but a lot of goes behind in terms of calibrating the overall different ECUs which form part of any vehicle. It's not only specific to EVs, it's any vehicle. As the vehicles are becoming more electronic dependent and controlled, the programming and integration of different ECUs is becoming very important. So integrating the conventional ECUs with the ones which are derived from the EV specific, like the battery management systems and other issues. So it has been an evolution which is largely based on the data which has been accumulated from the performance of the vehicles.
Absolutely, and I think what it is going to further impact is the kind of customization that will increase. I think more and more, and I think the customer requirement, and I think multiple use cases for today. Most of them it's the second vehicle, but for a few of them definitely is the first or the
Um,
primary vehicle.
Yeah, definitely. Infrastructure development is also on the fast pace, and as
Yes.
such, as mentioned by somebody mentioned that even the government policies have also undergoing change in terms of getting completely built vehicles from outside, vis-a-vis as compared to the building vehicles in terms of PLI scheme or FAME scheme and different schemes which government has laid out. But definitely, they will all form a very important role in defining the roadmap of EVs and their faster adoption in the country as we
Yes.
progress.
Yeah, absolutely. And given the kind of customization which is there, I mean, if you look at even in two-wheeler space, every model has already 3 4 variants, right, similar to IC. And maybe Ravindra, quickly, if you can touch upon how smart manufacturing can help bring in the customization and streamline processes around that to cater to different customer preferences and requirements. That will be quite useful to the audience, I guess.
Yes, thanks, Pratik. I just mentioned about that the digital manufacturing and PLM framework, I'll just touch upon that how this becomes the smart manufacturing, right? So, having said about the digital twin, and then now there is a term which always we use, the kind of OEE, overall equipment effectiveness, where we track and monitor availability of the machine and the performance and the quality. So how this makes the smart is that how we machine and equipment and process on the shop, we make it a smart. When we make it a start means it start connecting with the neighboring machines and others, and it start transmitting the data, and we can collect it to that. So here we call a kind of a manufacturing execution system or manufacturing operations planning. So here, when each machine is connected, then we can measure and connect, like what is the availability of the machine, what is the downtime of the machine, which machines is getting the bottleneck, where is the rework, how we can eliminate it, is that how many parts are being produced. So here, the smart manufacturing enables that to collect the data and put as a kind of dashboarding, and not related to that event but the energy and utility, which all we can manage it, and you can dashboard it created. So this makes a machine very smart. What we said about the digital twin in the physical environment, the moment we start measuring, dashboarding, and looking at the dashboard, it's very nice to control it, focus it, and on the process live environment you can control it. And here plays the IoT or AI and other algorithm, even the related to the maintenance of the machines. Everything is connected, and this is the way we tracked, and we improve the kind of the productivity and the cost saving, and the entire thing ecosystem is made the benefited and improved.
Giridhar, I think you also had a point of view on this in terms of why there will be further
Yeah, actually,
complexity being built out in the EV manufacturing, and I think customization definitely is going to be a very predominant theme as far the offerings are concerned in the market.
yeah. Actually, in the EV space, what happens is, the kind of varieties that the OEMs have to offer are proliferating a lot. For example, in the two-wheeler market, you mentioned two-wheeler markets, and we are dealing with one of the two-wheeler OEMs. And in two-wheeler markets, what so happens, there is an L1 and L2 category of vehicles. L2 is a higher speed, and L1 is a lower speed. This is mandated by the government. And again, in these, there are two kinds of customers. There are one is a B2B customer and a B2C customer. And a B2C customer, one requirement is coming from where, these 10-minute quick commerce deliveries. You need to deliver in 10 minutes. So you need high speed power and, typically less than 10 kilometers driving range, but then the vehicle has to go really fast. And on the other side of it is, there is another B2B business where they tend to run the scooters on a 24-hour basis. For example, in the mornings, they will run it to, collect blood samples from morning 5 to 7. From 7 to 9, they'll have breakfast. And from maybe around 11 o'clock, the Pizza Huts and other things start. And then they take up some of these, Flipkart, Amazon deliveries. And again, they keep running these scooters throughout round the clock, almost round the clock. So the requirements that are coming from the market are tremendous. And so this puts a pressure on, the vehicle configuration that is being delivered. So the OEMs typically end up with offering 15 or 20 configurations on every vehicle. You want a high-speed vehicle, low-speed, high-speed, low range, low-speed, high range. And these are what are the kind of load you want to take, and all those kinds of things. And here, this is where a digital twin, it's connecting, it's the, let's say, I would call this as the operating system of the EV OEM. On the one hand, it connects to the dealer management system. So where it collects these requirements and feeds them to the manufacturing for a good production planning. And so this is where a good digital twin, which encompasses which leverages all the data, AI, and stuff like that, and helps to not only do production planning but also the PLM on the other side. So we ought to be going towards a more holistic system rather than the current system, which is all in working in silos. So this is how the digital twin helps.
Great, Giridhar. I think we talked about a lot on digitalization, smart solutions like digital twins, etc. I think, but one of the also imperatives for all of us is how do we ensure that we are also doing sustainable manufacturing or green manufacturing for that matter. And Vivek, if you could throw light on some of the green manufacturing practices that need to be looked at or already being leveraged as far as EV manufacturing is concerned, and also taking it a step forward, how are you also working back with your suppliers to you know uh, sort of encourage them towards sustainable manufacturing practices?
See, it's not exclusively for EVs, as I mentioned, because EVs, in all likeliness, they have one particular percentage of specific operations over the regular conventional vehicles. So, as I mentioned, that Tata Motors is actually pioneering in sustainability in the sense that we are the first company from India who is applied for uh, a lighthouse in sustainability, which is something which I can feel proud of. And in sustainability, the levers that we apply is most importantly in terms of if you talk about the value chain is the circularity. So circularity is again being driven in a very strong manner in terms of right now as we speak we have formulated a plan in the sense that in the entire value chain, right from the raw material which is being used by the suppliers, tier 3, tier 2, tier 1 suppliers, to the materials that are being used by us, and also the vehicle which is being used by the end customers, and the kind of materials like the oils replacement or the filters which go for replacement after a period of time. So all these are being put into the scanner and trying being looked at from either using the material which is green, which is sustainable or recyclable, or trying to find multiple usage of the same material at with from one form to the other, so that the life cycle of the raw material which is being used, which is multiplied, so that we have lesser impact onto the environment. So this is one part on the circularity. Second part is on the greenhouse gases and the kind of kg CO2 that we generate. So we are firmly on the road, on the path of using the green energy over gray or black energy, as we call it, the coal energy or the other conventional power that we use. So we are banking largely on the solar energy. So we generate about 17.5 megawatt from Pune site itself, which is about 40% of the green energy which we generate in house. And then this is basically would impact in terms of reducing the impact onto the carbon footprints as such. On top of that, there are initiatives on to the processes that are being used. So if I say that in automotive manufacturing, or let's say in this case EV manufacturing, during the painting process, we have a process of doing the painting, which is using ovens, which are using which use usually either they use electricity or they use the LPG or CNG as a fuel. So we are trying to optimize on that part, trying to go from fossil fuels to electric, and then when we say electric, going using the green energy over there. This is one part. Second part is that we are also contributing into going basically reducing the waste which is being generated into our through our processes like paint shops and all. So we generate a lot of sludge, which is hazardous material, which has to be either incinerated or it has to go to the landfills. So we are going to use the either new technology in terms of paint, or there is a new technology which is called the dry booth technology, which will significantly reduce the impact on the generation of the hazardous waste into the environment. So that's one. And definitely it will also have reduction in the consumption of the fresh water, because all auto OEMs, they use lot of water in processing of the manufacturing vehicle manufacturing processes. And one more part is how we optimize the recycling of the water, in the sense that we do the recycling, we put it through the RO process, and then we process the STP or the ETP, and then we make sure that not more than 2 or 3% of the water which is there, which is actually a very high target. Usually it is at this point of time about 15%, and that is also being used for the gardening purpose. So the whatever water is being used is actually used within the premises for one application or the other. So these are some of the initiatives in terms of water, or the power, or in terms of the generation of waste, or having the circularity in the materials that we use. So these are some of the initiatives which are driving our processes, and we this is in process of getting extended into our first in or to our tier one suppliers, and then further beyond. That is the plan from Tata Motors at this time. Yeah.
That's quite commendable, Vivek, and definitely Tata Motors is at definitely the forefront of bringing and creating benchmarks in sustainable manufacturing. And I think kudos to you and the team to be doing that. I think what we'll do, given the paucity of time, Priyanshi, maybe we can take few questions from the audience. We still have 10 minutes to go. And I can already see a few questions coming in the chat window. Uh, One question from Sudhakar is on standardization of battery packs. And maybe Rabindra, if you would want to take this, and where the industry has reached as far as uh, bringing standardization in battery packs, and would like to throw some light on that. And what do you see the outlook
No,
on this?
it's a nice point, Pratik. Is fine. It's a nice point, and that all this kind of innovations and the iteration and improvement is done at the design stage, and getting feedback from the manufacturing also, because manufacturability is very very important. So multiple types of iteration on the battery pack standardization is done in the digital environment, and I say that is taken care by the design department with all various streams, and this is the way what we improved it, and that kind of scenario is created in design, and we simulate in the design environment to come up with that, and we see that how digitally manufactured. So these aspects is done the digital twin kind of environment, and then before we putting into the physical in the product.
So I'll add to that, Pratik. The battery pack standardization as such, in terms of the composition of the battery cells going into a battery pack, and then so on and so forth, is there. But the battery pack from the OEM perspective is also being driven out by the packaging within the underbody of the vehicle. So uh, it's battery packs are largely a big size of they acquire large size. I would say that, say, may about 1.5 meters wide to, say, about 2 meters, or 1.5 1.8 meters long. So that is the area which they occupy. And underbody is one busy area in a vehicle, every vehicle, wherein all the brake lines would pass, all the different kind of cables would pass from below. It is, while customization is there, but it has to really be sensitive about the overall vehicle architecture, as such, because it has to be a mix of both, I would say.
Got it. So we have the next question on battery health from Gaurav. What are the typical beyond ambient temperature which impact the health of a battery and the subsequent range that the battery is delivering? Anyone
Uh,
can pick it up, Vivek,
So
Ravi.
I would talk about the battery health. So in electric vehicles, we have, like, we have a coolant system, which is in ICE vehicles, which is going around the engines and all. So we have for EV vehicles, we have two kind of coolant systems. One coolant system is for definitely the electric motor, but the second one is for the battery pack. So the ambient temperature which has to be maintained, just like we have a temperature control for the powertrain, we also have a temperature controlled through the coolant system for the battery packs also. So that is what takes care of the temperature part, and thereby the overall longevity of the battery.
And to just to add it, Pratik, and what practically also Vivek mentioned about it, and before doing the physically, this environment is created, simulated in the CA environment, and based on iteration improvement, and then we try it out with the prototyping, and we see that how impacts created, and feedback goes back to the digital environment design and the product validation. We improve it.
Sure, sure. Uh, do we have any more questions, Priyanshi? Anyone from the
So we
audience?
can close it. So I would like to thank all the panelists and a very special thanks to Pratik sir for superbly moderating the session and managing it so well. So we have come to an end to this webinar, and a big shout out to our attendees for extending your time and support for this event. And we promise to come back soon with another exciting session. And don't forget to join us at the EV Manufacturing Show 2024 on 23rd May, Radisson View, Bangalore. And stay ahead in the world of electric mobility. Thank you so much. I'm playing the short video of e-mobility show again. Thank you
Okay,
so
I'll
much,
be
everyone.
Thank
signing
you.
out. Thank you.
Thank you. Thank you. Bye.
Thank you. Take care.
Bye.
Electric vehicles are changing the way we move. There is a sustainability in motion. It's silent but powerful. The future of transportation is here, and it's electric. Gear up for the biggest EV manufacturing event of the year. EV Manufacturing Show 2024, powered by eMobility Plus.
Thank you so much, everyone, for joining us today. And take care. And we'll look forward to host you in EV Manufacturing Show 2024. Thank you so much once again.